Hey guys, let's go over this review. I'm going to try to go as quickly as I can. So, as you remember, this is the parent function, so there's no translations for the parent function. The vertex, on the other hand, is going to be 0, 0. So when you're doing your t-chart, start with the vertex. Do 2 below it, 2 above it. Now, we've seen this 100 million times, plugging in the x squared. Remember, when you're plugging this in, it's negative 2 parentheses squared, not this. You'll get the wrong answer when you do this. So, the answer should be 4, 1, 1, and 4. Plot your points. So, negative 2, 4, 1, 2, 1, 2, 3, 4, negative 1, 1, 0, 0, 1, 1, 2, 1, 2, 3, 4. And try to connect. I've seen better. Well, that one's done. Boop. Again, I'm not going to put pauses in here. I'm just going to try to fly through it because you should already have it done by now. In fact, all right, sorry about that. I had to get water. All right, transformations. Don't see a negative. I don't see any A for stretch and shrinking. Strange things happen in parentheses, so we're going to be going right by 3. Got a minus 1 there, so we're going down 1 by 1 if you want to throw the by in there. Vertex. Again, strange things in parentheses, so positive 3, negative 1. Let's come down here to your T-chart. 3, negative 1, 2 below it, 2 above it, and we need to plug it in. Let's see. Let me rewrite it right here so I can see what we're doing. Was it minus 1? Yeah, it was minus 1. So if I plug in 1, 1 minus 3 is negative 2. Negative 2 squared is 4. 4 minus 1 is 3. 2. 2 minus 3 is negative 1. Negative 1 squared is 1. 1 minus 1 is 0. 4. 4 minus 1 is 1. 1 squared is 0. Yep. 5. 5 minus 3 is 2. 2 squared is 4. 4 minus 1 is 3. Good. Then plot your points. 3. 1, 2, 3. Down 1. That's the vertex. So 1, 3. 2, 0. And right there. I don't know why I did that. Connect your dots. I was trying to do axis of symmetry. Didn't ask for it, but I mean, remember, it goes through the vertex, which means this equation is x equals, in this case, tree. All right, moving on. There's no negative. There are 3 is here. It's greater than 1, so we're stretching by 3. Nothing's being added or subtracted in parentheses here. Plus 2 means you go up. Vertex is going to be 0, because again, nothing's being added or subtracted. And 2. Come down here to the T-chart. 0, 2. Negative 1, negative 2, 1, 2. Again, I'm going really fast because you should already have this done. If you want to stop, you can hit pause. Plug in negative 2. Negative 2 squared is 4. 4 times 3 is 12. 12 plus 2 is 4. Oh boy. 14. Negative 1 squared is 1. 1 times 3 is 3. 3 plus 2 is 5. And then it should be repeated. 1 squared, 3, 4, 5. Good. 2 squared is 4. 4 times 3 is 12. 12 plus 2 is 14. I don't know if I have enough space for 14. We'll see. Negative 2. Oh, let me scroll up a little more. Negative 2, 1, 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Nope. Negative 1, 5, 1, 2, 3, 4, 5. Skadoosh. 0, 2. And that one was 1, 5. Just like that. Boop. So we got negative, so there is a reflection. A quarter is less than 1, so there's a shrink. 3, got to think opposite, so left. 3. And then 2, we go up to Vertex. Again, going really fast. Negative 3 because of strange things in parentheses, or stranger things. Haha, funny, funny. Negative 3, 2, 2 below it, 2 above it. Let's see, what was it? Negative quarter x plus 3. Whoopsie daisy, that's on the wrong side, isn't it? Parentheses squared plus 2, I believe. Yep. I'm probably going to need my handy dandy calculator. I'm going to use the Desmos one because that's make my life a little easier. Boop, bam. Now you can't see this because I don't have a calculator in this computer because I'm at home. But I'm telling you right now, I'm plugging it in just like I see it on the computer. Parentheses, negative 5, plus 3, squared, plus 2. So when I plug in negative 5, I get 1. I'm simply going back. Ah, criminy. Simply going back. Sorry, I got sausage fingers. 4, we get 1.75. Let's see, hit back. 2. Good, we get 1.75 for that. And then back 1, and we get 1. I'm saying back because I'm changing the numbers. So, go ahead and plot those. Negative 5, 1, 2, 3, 4, 5. Up 1. It's just up 1. There we go. Go back 4. 1, 2, 3, 4. Up to 175, which is right about there. 3, 2, 1, 2, 3, 1, 2. And then it should be kind of symmetric. And it is. Negative 1, 1, 1. Skadoosh. Let's keep going. Boop. Now, when you do this part of the test, or quiz, or whatever, it's multiple choice and you're picking the right graph. But you should be able to write an equation off of this. First, let's look at the vertex here. Should be negative 3, 1. So if I was filling this vertex formula in, I know what the h and k is. K is 1. And the h is going to be not negative 3, but positive 3. And as I told you all in class, you go over 1 unit and then go to the line. In this case, we went 1. So 1 and 1 is 1 over 1 because rise and run. So it's just 1. I don't need to put the 1 right here. Now, it is opening down. So we went down, so that's a negative 1. Should be a negative in front. The negative is important, not the 1. But if you want to, put it in there, whatever you want. Again, real quickly, vertex is right there. So that's 1 tree. Plugging this in, we've got to do opposite for the x, so negative 1 squared plus 3. This one we go over 1 and up 1, 2. So that's 2 over 1, so 2. Positive 2 because it opens up. Boop. Vertex here is going to be, I'll try to make it 2. 2, 0. Alright. And if we went over 1 unit, that puts us at that 3. And then go up to the line. And honestly, just eyeballing it, looks like it's going to be negative 1. So I have everything I need. Negative parentheses, x minus 2 squared. And we do not really need to put this 0 here. Okay, so I'm just going to delete it. Boom. Answer. This one move down. So that's 0, -1. And if we went over 1 up 1, so it's 1, 1 there. So, again, we don't need the imaginary 1 there. Well, I mean, we could put imaginary 1 there. X squared, because then it'd go left or right. I really don't even need those parentheses there. So you know what? I'm just going to dress all this up real quick. This should just be x squared. And frankly, we just went down 1. So subtract 1. Alright, let's keep going. Now, this says convert the vertex form to standard form. We're supposed to be going to standard and vertex and vice versa. I'm going to do that for both problems, just so we know we did the right thing. So, from here, remember this is x minus 3. X minus 3 because it's being squared. You can do the Punnett Square if you wish. Let me get rid of this extra stuff. Or you can do this in your head. For example, you should have x squared minus 6x plus 9 minus 1. Let's try it out. If I did the Punnett Square, x minus 3, x minus 3, x squared, -3x, -3x, plus 9. This is 9. Two negatives make a 9. 3 times 3 is 9. Add the diagonals. And indeed, we do get the same thing. Combine like terms, and you get 8. Now, really quickly, I'm going to go right back to vertex form using the formula. You're supposed to have this memorized. H equals -b over 2a. Okay? Side notes. A is 1. B is -6. C is 8, but we don't need 8. So plugging this stuff in, we got -6 all over 2 times the 1. 2 negatives make a positive, so what we really have is 6 over 2, which is tree. H equals tree. Our note said to plug that back into the formula, or to the equation. So 3 squared minus 6, 3 plus 8. So that's 9 minus 18 plus 8. Let's see, 18, -18 plus 8. That make that -10. Add 9, we get -1. Remember, that's K. And when we stick everything in, don't forget the A part, we're plugging it into the vertex formula. So A is 1, x minus 3 squared plus a minus 1, but let's face it, we can just put a -1 right here. And indeed, that's the problem we started out with, so we did the right thing. I'm gonna go to bed. Alright, I'm skipping the Punnett Square because I can multiply this in my head. So -2 x squared plus 8x plus 16 plus 5. Then you have to distribute. You got to distribute to everything. -2x squared minus 16x minus 32 plus 5. Combine like terms, -2x squared minus 16x. And that should be 27, -27. So there you go, standard form. I need to go get more water. Be thirsty like that. But let's keep going. Change back to red. A, -2. B, -16. And C is -27, but we don't need it. Ugh. All right. Negative b over 2a. So negative 16 over 2, negative 2. So positive 16 on top. Two negatives make a positive. 2, negative 4. 16 divided by negative 4 is negative 4. And that's our h. So far, so good. All right, plug that back in. So negative 2 times negative 4 squared minus 16. I mean, I'm going to need my calculator for this. Minus 27. Negative 4 squared is going to be 16. 16 times negative 2 is going to be negative 32. And for the life of me, I don't remember what 16 times 4 is. I feel like I know that in the back of my head, though. 64. I knew that. Add 64 minus 27. So I know 64 minus the 32 is going to be 32. So then 32 minus the 27 is going to be 5. And that's K. Again, using this formula right there, plug in what we know. We know A is negative 2. We know X is going to be, see, minus a negative 4. Two negatives make a positive. We square that and bring down the plus 5. And let's check. Yes, that was the original problem. So we did the right thing. Okay, again, memorize negative b over 2a equaling h. Remember this. Boop. All right, we're almost done. And I'm glad. I need to go brush my teeth and go to bed. Vertex is right there. Negative 3, 1. Told you 1,000 times, axis of symmetry is going through the vertex. And you use the x part of the vertex. This one is a maximum, and it's going to be the vertex. Domain, said 100,000 million times. It's all real numbers. Range, how low can you go? Negative infinity. How high do you get? 1, inclusive. Intervals of increase. Remember, you're reading this graph left to right. So if you're on this side of the mountain, you're going uphill. When you get to the top, that's when you start to go downhill forever. You know, tumbling, me tripping downstairs. Anyway, you know, like rolling and don't get me started. So, intervals of increase, left side of the mountain. This little dude came from the negative infinity side of the world, and he will continue to go up until he hits negative 3. Okay, remember these are x values, negative 3. Once he hits negative 3, that's when he starts going downhill. So negative 3 to infinity. And again, these are x values. Okay. Zeros is where it crosses the x-intercept. So negative 4, negative 2. If you want, you could put x equals negative 4, x equals negative 2, whatever floats your boat. X-intercepts are points. So negative 4, 0, negative 2, 0. Now, since we have a graph, I'm going to do rate of change by counting it on the graph. So let me erase all this gibberish. There you go. Negative 3. Again, these are x's. Specifically, negative 3 is x1. Negative 2 would be x2. So, negative 3. Go to negative 3. Go to the line. Boom, put a dot. Negative 2. Boom, put a dot. Rise over run. We went down 1. To the right 1. Rise was negative 1. Over run, which was 1. Our rate of change is negative 1. Skadoosh, and I think that was it. Let's check. In behavior, as x is decreasing or going to negative infinity, the y's are going down to negative infinity or decreasing. As x is increasing or going to positive infinity, the y's are going down to negative infinity or decreasing. And remember, in class, we discuss both of these are going to be the same. Okay, remember, opening down means they're both negative infinity. Opening up would be positive infinity. Boop. Vertex, I think it's already labeled for you. 2, -9. 2, -9. 1, 2. This thing's going by threes. Let's not let that get away from us. You see that, guys? This is -3, -6, -9. Do you see that? -9. Whoo wee. 2, -9. Put that for vertex. Axis of symmetry. Done deal. There's no max because it's a valley looking shape, so is a min. Again, still vertex for that. Domain, all real numbers for ooh. Ooh, I can't say that. I cannot say that about this one. Did I make this mistake on this one? No, no, this one we're going to argue goes on forever. This one, no, notice. Oh man, I was really jumping the gun for this one. Look, there is a gap. See that gap? We cannot just simply say all real numbers for this one. No, we're gonna take an educated guess here. I'm gonna argue this is like a -2.5 in my opinion. This one we'll give it a 6. We'll give that one a 6. So inclusive -2.5 to the left and all the way to the right is going to be a 6 inclusive. Ooh, they tried to trick me. Ooh. All right, we got -9. That's how low we can go inclusive. But how high we get, that's something else. Because remember, we're counting by threes. 3, 6, 9, 12, and this is 15. 15 inclusive. Ooh, boy, y'all better be careful. Intervals of increase, it's flipped upside down, so when we get to the 2 is when we start to go uphill, and over here is when we've been coming downhill. So increase, we're going to say from 2 to infinity. Decreasing is negative infinity to 2. Again, x values. Zeros, that's easy. 5 and -1, so -1. I'm going to use fancy brackets for this. X-intercepts, no dir, should be -1, 0, because it crosses the x-axis at these points. Y-intercept, eyeballing here, we got -3, so that'd be 4, 5. I'm going to say 5. So 0, -5 for that bad boy. 2 to 4. Alright, I'm going to erase some stuff just so I can see. There we go. It says 2 to 4. So 2 is right here. 4 is right here. And remember, that's 9, that's 6. That's gonna be -5 right here, like we said earlier. So let's keep this in mind. When you go up, okay, we're not going just up one. We're going from -9 to -5, so that's 4 units. And then we go to the right, 2. Rise over run. 4 over 2 is 2 will be our rate of change. In behavior, we've gone over this on the last slide. It's opening up. These bad boys should be infinity. As x is going to the left to negative infinity or decreasing like we talked about today, the y is going all the way up. And as x goes to the right to infinity, or is increasing as it says, the y's are on the way up. So infinity, infinity. I think that was it. Oh boy. Put a little smiley face there. Alright, good night.